Okay, good afternoon, good morning, everyone. Thank you for joining us in this webinar with Liqid and GPL Technologies. My name is Memo Rojas. I am from the marketing department of GPL, and I'm very glad to have you here today with us. George Wagner from Liqid will be presenting us very interesting content about composable infrastructure and many other things. You can ask us questions either on the chat or you can raise your hand. We will have a Q&A at the end, so feel free to interact with us, and welcome again. Thank you. So go ahead, George. Thank you so much.
All right, thank you, Guillermo. And thank you everyone for taking time out of your busy schedules to join us today. My name is George Wagner. I run product marketing and technical marketing here at Liqid, and I'm joined also by Blake Scott, who is going to be my wingman today, and in case I get asked any questions that are too technical, and he's also going to provide kind of an insight into our user interface towards the end of the presentation. I want to be mindful of the time, so let's just kind of dive right into it. You kind of set the stage for what we do. If you haven't heard of Liqid before, our goal is really to help customers transform their static server environments and trapped resources into dynamic servers that essentially meet their exact workload requirements. And what I want to do today is give you a brief introduction to Liqid, and I'll dive into some use cases to give you a better understanding of how we can help you solve your business problems. And I happen to know, because of your relationship with GPL Technologies, that many of you on the call today are probably in the media and entertainment business. And I also know that workloads that you deal with, such as content creation, rendering, post-production, even AI now to kind of eliminate some of those mundane tasks, are extremely graphics and storage heavy. And creating systems that are able to handle that, to handle those challenges, not only permanently but also temporarily between films, right? So you have different needs. Being able to stand up and tear down systems quickly, as quickly as you need them, is extremely important. So hopefully, what we can do here is, we understand time is money, so we want to help you be more faster, more efficient in the way you do your job. And when we look at kind of the way that traditional IT is delivered today, look no further than the server, right? Your typical standard x86 servers. The same ones that have been around for 30 years now. Blake and I were both in IT in prior lives, and nothing's really changed except for the power, right, and the performance. So what we're looking at is simple systems that are strung together, and the main challenges are they are inflexible. So configurations are fixed at the point of purchase typically, right? You're buying a system to meet an application requirement. There's usually a 3 to 5 year investment, right? You put that money in, you're investing for 3 to 5 years, but they're pretty static. Right? They don't change a whole lot after you buy them. But what if your workloads change, like in your case? How do you scale? Well, you're limited by the number of PCIe slots. You're limited by the form factor, by the combination of GPUs, NVMe, FPGA, et cetera, that can be added. If you do have room, that's great. But downtime typically needs to be scheduled for upgrades. And if there is no more space, then you end up buying a new server, right? So from just a simple delivery standpoint, those systems are pretty inflexible. I can definitely speak to that. On top of that, any resources that are inside of a single server or inside of a blade are unusable, right? They're trapped. You can't use them anywhere else. And so if they're not being utilized there, they're being completely unutilized. And that leads to poor utilization. In addition to that, I think I can speak for you all on the phone today, especially if you're dealing with very demanding workloads. We tend to over-provision to meet peak workload requirements. So we buy extra NVMe flash or SSDs. We have extra GPU horsepower under the hood just in case right? We need to be able to do rendering or whatever you need to get done in a timely fashion. However, if it's not being used, it's pretty wasted, right? So resources like NVMe, all that's trapped in the box, can't be used. It leads to problems with CapEx and OpEx. So these technologies, they've been around for a long time, and over time there have been new technologies introduced. I keep looking at the phone, but you're right in front of me. There have been new technologies introduced that try to make it a little more efficient, right? Like virtualization, converged infrastructures like HCI and converged infrastructure in general. But at the end of the day, those all the underlying resources that they consume are these x86 boxes, very rigid, inflexible boxes. So the good news is, believe it or not, we have a solution, right? Imagine that. And what we do at Liqid is we actually have a technology called Composable Disaggregated Infrastructure, or CDI. And the way you can think of it is really a new way of building servers in the data center, except for instead of plugging devices into motherboard slots, right, to define the server, we actually allow you to create, scale, reclaim servers on demand with software, right? So it's very, very flexible. And you don't have to cut your fingers on the inside of a server trying to change things out. And to enable this, you have to kind of suspend disbelief, right? People have told me in the past, this is magic. It's not really magic. It is definitely pretty special stuff. And what we're doing is, the first thing we do is we create resource pools. So we just aggregate, CPU, GPU, NICs, FPGAs, and we place them into what we call expansion chassis, which are connected along with the servers to high-speed fabric. So fabric can take the shape of PCIe, Ethernet, InfiniBand. So I'll pause here for a second, and I'll kind of state this. What we're doing is we're extending the motherboard beyond the server itself. That's one way to think about it, okay? All we're doing is we're putting a host bus adapter in that server, and we're connecting it to a PCIe fabric, right, so a switch, and then we're taking all of the resources out and we're plugging those into an external enclosure, so now they're not trapped in a single box, so at this point, before we even add software, we've essentially expanded our resources across the network. This is kind of where Liqid Command Center comes in. This is our software, right? Kind of the secret sauce. It resides on the fabric and allows you to create right-sized bare metal servers in seconds. Okay, so now what happens is you take Liqid Command Center, and I say, okay, I want you to make me a server with two CPUs, 4 GPUs, 4 NVMe's, 2 SSD, 2 NICs, right? And just like that, it's just like I plugged it directly into the box, except for I've simply defined it in software, right? So it's almost like Pinocchio, right? Pinocchio thinks he's a real boy. These servers think they're real servers, except for we just defined it all in software. And on the other side, I have a real server, bare metal server, to the exact requirements of any application I need. And you never need to over-provision. That's the great thing. Or you give an application exactly what it needs. Do you need to scale? Well, it's dynamic, which means if you need to add more resources, you simply use the software to add whatever resources you need, and you never have to crack open a box again, which is pretty amazing. Also, you're not limited by the PCIe slots in the server, so if you wanted to add 16 GPU to a 2U server, you can do that. We call it creating the impossible. You're not worried about GPU slots in the box anymore. You're no longer stymied by that. You simply add resources at will. And the cool thing here is once your project is over, if you have a project you're working on, for example, and once it's over, you can simply return the resources back to their pools and spin up another server when the time comes. Right, so you use the software to bring resources back into the pool and then spin them back up. It's managed through a UI. We have a GUI, which Blake will show you. We have an API. We have a CLI. So it's real simple. It's also fabric and device agnostic, so you can choose any vendor you want from a server perspective. And if you wanted to add more down the road, you simply add another box, right? Add another box. This time I needed FPGAs. Add those directly into there as well. So it's very straightforward. So how are we seeing customers use it in the field? Well, I'll show you a couple of examples. First one is a transportation company in California. It's a 24-hour operation, but 5 p.m. to them looks a lot different than 3 in the morning. So their challenge is that they're playing a game of kind of workload matching, right? So if they had a small workload they want to throw on a server, and it was a small server, all is great. But if it's a small workload on a large server, then they're wasting resources. So what they did after partnering with Liqid is they studied each workload's infrastructure needs and created kind of these T-shirt sizes, if you will, of different server configurations, so small, medium, and large. And when it was time to run the applications, they simply spun up the right size server based on its needs. And when it was done, the free resources were then returned to the pool. So you can use, so all other workloads have access to that $10,000 GPU, right? So instead of just sitting there not being used half the time, it's put back into the pool and used later for the next one they spin up. So it's just a great example of maximizing resource utilization using CDI. The next one may be very interesting to you guys, although I just went forward. There we go. And this is, we're partnered with a media and entertainment company there in Southern California. And they had, their challenge is they had 2 workloads that required GPUs. All right, one was for the AI engineers who worked during the day, and a second was for video rendering. And both workloads required 8 GPU. When they worked with Liqid, all they did was they just bought 1 tray of GPU, and then during the day they composed those GPU to the AI engineers. And when they go home at night, they then reprogram the fabric and give those GPUs to the video rendering servers. Right? So if you think about it, without Liqid, they'd have to double their number of GPUs. And instead of thinking that they're running at 100% utilization by just running them during the day, they could run them 24 hours a day, allowing them to majorly increase their ROI on those GPUs. And I think we all know, if you're in the business of procuring hardware, you want to be in the CFO's good graces, and being able to do this absolutely allows you to do that. Because if you can prove that you're using these 24/7. There's no question that if you really need one, you're asking for one you really do need one. But this is an excellent example of being able to just provide that flexibility across the data center. I know that also there are AI is beginning to be more prevalent in entertainment and media, especially to automate those kind of mundane tasks that need to be done. Enterprises are also turning to it quite a bit as well. And so this infrastructure works really well with AI infrastructure or AI use cases as well. And the one thing to remember here is that AI it's not an event, but it's actually a workflow. And then each phase that it goes through, whether it's ingest or cleaning and tagging, training, inference, they all kind of flex different resources in the data center. So the data ingest phase is very network heavy. When we clean and tag, it's a very CPU intensive process. It's probably also very impressive. We move on to training phase, which is GPU intensive, and then inference is its own as well. But most importantly, at the core is data, and I think it's a very sensitive topic for you all, because you're generating massive amounts of data. Right? And data has gravity, and it's difficult to move between different systems, and that's where a lot of the bottlenecks come into play. Right? You're trying to move massive amounts of data between different compute systems for different purposes, and the network becomes the bottleneck. Well, Liqid makes kind of these stateless devices easy and simple to move around. What we can do is we can recompose the storage into each one of those servers as it moves along the workflow. Okay, so we can start off in data ingest, and we can recompose that storage RAID and all, into that clean and tagging area, right? And then the training, and then an inference in just a few minutes versus having to wait hours to move terabytes or petabytes of data between those systems. So, just another example of really being able to create way more efficiency in the business, right? And once again, time is money, especially if you're on deadlines, you're trying to make things happen. It can be a real pain. So what are our deployment options? So I kind of talked about the software, but what does it look like? So we're essentially a software company, but we do offer some enclosures. They're kind of our vehicles to get our software out to market. So we have, on the left side of the screen, we have our PCIe switch fabric and software, which is kind of core to what we do, and the command center software. And as far as the switches we offer PCIe switches. If you wanted to use, let's say, Ethernet as your fabric, you could go to Broadcom and pick up an Ethernet switch. You can actually run multi-fabric, so GPU over PCIe, and then NVMe over fabric over Ethernet as well. We can do multi-fabric as well. On the right side of the screen, you can see we call it J-boxes, so just a box of flash, of networking, of compute. You have FPGA SSDs in that one down in the left-hand corner. That's kind of, in my opinion, probably the most interesting box we have. We call it the Sumo, and it can hold up to 20 GPU, and I'll show you that here in just a minute. As far as putting it together, though, it's quite simple, right? It's a host bus adapter in a server. I show a Liqid server there, but it could be any server. It could be your Dell server, your HP server, your Lenovo server, your homegrown server, you name it. If you have it would help to have a by 16 Gen 3 or 4 slot in your server, but you simply plug a host bus adapter into your server, plug it into the switch, plug your box of resources into the switch, and go. And use the command center software to provision servers on the fly. I mentioned that box, that Sumo box. So it is a 5U chassis that can hold up to 20 full height, full length GPU cards, and we've qualified AMD and NVIDIA cards. So as long as they're not desktop cards, workstation cards, you can put those in here and connect those directly to a server without a switch, because there's switching built into the box itself, and end up with a very high performance system that can get you. We own the ResNet 50 performance number. We own the V-Ray benchmark. We own the Octane benchmark. We own the ResNet 50 benchmark. All of those. So this is a very, very fast system, very simple to put together, because it does not require a separate investment of a switch. It can if you want to, but if you have between 1 and 4 host servers, you can plug them directly into the switch fabric that's built into that into the chassis itself, so you can really change the different ratios of GPU to CPU you need, and because you're using Liqid's software, you can change that on the fly, right? You can give 8 GPU to one node, and then when a job is done, reduce it to 2 for the next one. You can do up to 16 if you wanted to a single server. As long as the BIOS recognizes those devices, you're good to go. But it's very, very flexible and very powerful. And we're seeing a lot of interest, especially in the media entertainment industry for this type of box, as well as AI, just general AI as a fact. One thing to understand is this is a bare metal server we're composing. So when we create a server in Command Center, it is bare metal. So you can put any operating system on there if you want. You can put ESX on there. It doesn't make a difference to us, right? You put whatever OS on there you want. and then run any applications on you want. So it's very agnostic in that perspective. There are no drivers. This is all bare metal. Our software discovers the servers and the devices through when they're plugged into our switches, and so we can manage that. So there are no special drivers or clients, agents need to be installed on there. As I mentioned also, it can be managed through an API, CLI, or GUI. API is great for northbound integration if you wanted to use an automation tool. We can definitely provide help there. And finally, that's kind of improved software license efficiency. You know, if you have an OS that's licensed by sockets or cores, sometimes you can't put enough resources in there, like GPU or NVMe. You have to buy another server. When you buy another server, you have to buy more licenses for your cores. With this, you can build massive servers that allows you to kind of sidestep those costly licenses. We look at what we're able to deliver from a value standpoint is really around three areas. The first one is increased flexibility. So as I mentioned, you can really create any configuration you want in seconds. It's vendor and fabric agnostic, so you can choose any devices you want. You're not tied into a particular vendor. It's I mentioned, open for any operating systems. From a speed improvement standpoint, it definitely improves deployment times. If you think about when you have to procure a server, the amount of time that takes to negotiate server costs, the server price, and then order it, and then wait 4 weeks to 4 months for it to show up, that's a long time versus just being able to spin it up in seconds, scale in seconds, and simple management. And finally, maximizing your efficiency. If you think about life before virtualization, VMware, we're talking about 12% resource utilization in a server. VMware upped that to maybe 40%, 50%. We can get upwards of 90% resource utilization, which means you're utilizing more of your resources, means smaller footprint, less cooling that needs to be paid for in electricity, and obviously lower licensing costs. So, let's see here. Let's see, what is next? Oh, so at this point, I'm going to pass it over to Blake. Actually, we'll pass it over to Blake to do a quick demo, and let's open it up for any questions you may have. Guillermo, if you wanted to pass the mic to Blake.
So here we're going to demonstrate composing a Gen 4 products into an Asus server. So here we see that the system currently has 2 devices already in place, an SSD and a NIC. And what we're going to do is just verify that everything shows up okay. So first, we see that the NVMe device is showing up properly. Now we're going to just check out the NIC, and we see that the Mellanox Connect X6 shows up properly. So now let's verify that they're both showing up as Gen 4. So we're going to jump into the LSPCI detail, and once we pull that up, we're going to be able to see that the link capabilities and the link status is at 16 gigatransfers per second. So here we see the link capabilities. We see that it's indeed 16 gigatransfers per second. And we see the link status also is at by 8. So that looks good for the Mellanox NIC. Now let's take a look at the NVMe device. So we're just going to hop out and bring it up. And we're going to look for the NVMe device, which is device ID 1987. And here we see that the link capabilities also is at 16 gigatransfers, and that the link status is showing that it did link at by 4. So everything is showing up really nicely on this Compose system. So now what we're going to do is we're going to honor a request. Say somebody requires a little bit more storage. The request comes in. We're going to go ahead and add a few NVMe devices. So we're going to click the plus minus add modify button. We're going to add in a couple of NVMe devices, and then we're going to hit reprogram. So now, as this is reprogramming, what it's doing is, on the surface, we've dragged and dropped hardware. Under the hood, it's establishing a raw PCIe connection using the magic of the Atlas chip. So it's connecting these NVMe endpoint devices all the way up to the host. So what's really nice about that is there's no agents to be installed. There's no Liqid specific drivers to be installed. Once the system detects the devices as present, it simply makes that available for the applications to look at. So now we're going to just hop back in and just verify that those composed devices showed up properly. So we're going to first look at LSPCI, and now we see that there are indeed 3 NVMe devices as we expect, and now we can just check out NVMe list, and we see that the system has detected that and it's ready to use that. So let's just double check that everything came up properly as Gen 4. So now we're going to bring up Gen 4. And we're going to just look at each of these NVMe links. So the first one, we see that indeed it looks like we have, yes, a by4 link. And then we're going to look at the next one. Now there's another by4 link. We're going to hit the next one again, and now we're going to see another by4 link. So we just went ahead and went through all 3 devices, and we showed that, verified that each one has a by4 link.
We also offer, besides the composable infrastructure, we also offer some of the devices that plug into the composable infrastructure itself, namely NVMe add-in cards and NVMe U.2 cards. So non-volatile memory express, pretty much the fastest non-memory storage available. We have half height, half length, and full height, full length cards. In fact, the cards we have are the fastest, literally, they are the fastest in the world. So like this guy, for example, this one might be interesting. It's we call it the Honey Badger. It's a full height, full length card that can get upwards of 4 million IOPS random reads and 1 million random write IOPS and 24 gigabytes of sequential reads and 10 gigabytes of sequential writes. So those can be plugged directly into a server, or they can be composed. So if that is anything that sounds interesting, we've just like the Sumo is kind of taken those the Resonant 50 awards, etc. This actually is the fastest flash device in the world, and we're getting ready to release one that's based on Optane here in the very near future, and that'll overtake it as well. But anyhow, this also works in non-composed environments. So for some customers, maybe they wanted to go composed down the line, but for now they needed some really fast NVMe flash that gives them that option. And that's all I wanted to show. Are there any? Yeah, you bet. Any questions out there?
Any questions?
If you have any after the fact, you can definitely shoot them over to Guillermo, and he can hand them over to us to have us answer as well. So it's no problem.
So yeah, I don't see anyone has any questions. So we are going to send you the link to this webinar. Is going to be published in YouTube and follow-up email where you can always ask us questions in case you need to digest the content, and we will be more than happy to present you with a more specific offering for your business. And anything else, of course, you can email us, either George or myself.
Absolutely. Thanks for the opportunity, Guillermo. I really appreciate it.
Okay, thank you, George, and thank you, Blake. So then this is it, and have a good afternoon, good morning still in the West. So, and thanks for joining us again. And we will post you as we are going to have additional webinars. There's a lot of great products from Liqid that we would like to show you. This is the first of many to come. Thank you so much.